Hello, hello, yes. We welcome you back to PSSB, Physical Sciences, Silver Bullet. And tonight we are still continuing with projectile. The question says that a hot air balloon is moving upwards at the velocity of 10 meters per second. When the balloon is at the height of 50 meters above the ground, a person inside the balloon drops a ball. Explain the movement of the ball from the moment it is dropped until it strikes the ground. Okay, how does it move? Okay, this is what the picture we have to know. That if you have this one as our balloon with people inside, and it is moving upwards, and the height is 50 meters. It's moving at 10 meters per second, and this person takes out their hand and drops the ball. Dropping means that she or he held the ball and let it go, not pushed. So what happens to the ball? This is what we are trying to explain. What happens to the ball is a bit different from what we know. What happens is that the ball is initially projected upwards. With an initial velocity which is equal to the velocity of the balloon. So it is projected upwards, and what happens? It reaches maximum height, and then it starts coming down. So continues to go down until it strikes the ground. If you are looking at the position time graph of this ball, it's going to be this, where this is the point at which the ball was released. It takes an upward projection with an initial velocity which is 10 meters per second. It reaches maximum height, then from there it starts to come down and strikes the ground. That is a bit different from what we knew. What do we know? We know that when the ball is released, it was supposed to come down under the influence of gravitational force. But yes, that's what happens. And let us put it down. Yeah, so that is it. The ball initially will be projected upwards with an initial velocity equal to the velocity of the balloon, which is 10 meters per second. It reaches maximum height, then moves downwards until it strikes the ground. That's what happens to the ball. Yeah, then comes this question. It says, calculate the maximum height the ball reaches from the point at which it was dropped. Okay, how do we deal with this one? Let us look at the data. Okay, what do we have? The first one, we have VI, the initial velocity of the balloon, which is 10 meters per second. We have to recall that the ball is projected at the same velocity as the balloon. Then we bring in the unknown. Unknown is delta x. Okay, what else do we know? We are talking about maximum height. And what comes with maximum height is velocity. Velocity at maximum height is known and is 0. Okay. Then what else do we know? We know G. I want you to recall that the moment you make your initial positive, because we put 10 meters per second, the moment you make it positive and the ball is going upwards, it implies that you have made upward positive. You don't even have to indicate that. So what does that mean? That G, which is always acting downwards, is negative. So it's going to be negative 9.8 meters per second squared. Armed with this data, what do? We look for the right equation. And the right equation is going to be Vf squared is equal to Vi squared plus 2a delta x. Okay, Vf squared is 0 squared, which is equal to 10 squared plus 2 times negative 9.8 times delta x. Okay, when you simplify this, you are going to get 0 equals to 100 plus negative 19.6 delta x. So what do you do here? You can bring that negative this side to become 19.6 delta x equals to 100. And from here we have now delta x, which is equal to that, giving you the answer, which is 5.10 meters. So this is the maximum height reached by the ball from the point of projection. And with that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. Yeah, see you next time. Don't forget to subscribe. Don't forget to like. Don't forget to comment and also to refer the channel to a friend. Bye-bye.